In this topic, we're going to cover how to create a custom Burp extension in Python. Before we are able to create our custom Burp extension, we first need to install and configure a few things. Firstly, we need to install Burp on our machine. So to do that, let's go to portswigger.net. Then we can go to Products, Burp Suite Community Edition, and we can download this for our Windows install. While that's downloading, we can also go to jython.org and go to download. And we can download the standalone Jython file, and we don't want the installer, we want the standalone file. And we want to keep the jar file once it's downloaded. And once Burp's downloaded, we can start the installation process. Next. We can just use the defaults here to get Burp installed. And finish to exit the setup. So now we're able to run Burp from this machine. And we can start a temporary project. And now that we've installed Burp, we can now set up Burp to use Jython. So we can go into the Extender tab here, into Options, and here we can see that we can specify the location of Jython standalone jar file. So this is why we needed to download the standalone jar instead of the installer, and we can select the location of this file, which is in Downloads. Single click and open it. And now that we've installed Burp and configured Jython, we're able to create our own custom extension. And to make our lives easier when doing this, there's a useful exceptions fix file that we want to download. So we want to go to github.com/securitymb/burp-exceptions. And here we can see this excellent repository, which includes a file which makes debugging our Burp exceptions much easier. So rather than seeing these kinds of exception errors here, which aren't really useful to us as Python developers, we will instead be able to see these more specific Python errors. So let's download this file, view it as a raw file and save it. And we want to save this into the directory where we will be writing our Burp extension. So let's save it here, exceptionsfix.py. And now we have all the pieces that we need in order to create our custom module. And when creating a module in Burp, there are certain API components that we need to use and interact with in order to communicate with the Burp core. And these components are dependent on which Burp features we are trying to use or interact with. And we can view the API documentation directly within Burp to see what's needed to interact with these different components. So for example, we can take a look at the iTab API, which we will be using to create a new tab within the Burp GUI. So another one of these tabs. We can look at the APIs here, take a look at iTab, and here we can see the interface which we need to interact with in order to use this component of the Burp API. And these are also documented here. So we can see that get tab caption, what this is for is Burp uses this method to obtain the caption that should appear on the custom tab when it is displayed. Or get UI component, Burp uses this method to obtain the component that should be used as the contents of the custom tab when it is displayed. And we're going to implement both of these in our module. And what are we going to be doing in our module? Well, we'll be creating a graphical user interface to interact with the unencrypted version of the bind shell, which we created as part of project number 5. Now, this isn't exactly a good example of what you would want to use Burp for, but this shows that by using Python and interacting with the Burp API, you have a lot of freedom to add or implement any feature you want within Burp. And so let's get started by doing that by importing a number of the modules that we're going to use. From Burp, import iBurp extender, iTab. From JavaX, import swing. From java.awt, import border layout. And these Java components are what we're going to use to create our graphical user interface here within Burp. And now some Python functions we're more familiar with, sys and time, modules rather. We're also going to import from the exceptions fix file which we downloaded, the fix burp exceptions function. Also import from socket, threading, and sys. We can save this already, burp underscore module.py. And as mentioned, we are making use of Java Swing from within Python. And Swing is just a GUI, graphical user interface toolkit for Java, which provides a number of widgets we can use as part of our Burp extension to create GUI items. So views, buttons, all of these kinds of components that you can currently see within Burp. These are just different Swing components. And this course is focused on Python, but we will be using Swing components within Python to create the Burp module. So in this lesson, we're not really going into detail on Java or Swing. We're just going to use some components here. So let's start by implementing the Burp extender interface, which is required by Burp for an extension, and calling this fix burp exceptions function to make debugging our extension much easier. And we also want to create a tab. Let's import fix burp exceptions. And let's first register the methods that may be invoked by the extension to perform actions within Burp. So let's register extender callbacks, self callbacks. And again, a number of these names and extension functions are defined by the Burp API. Let's add some variables here. Self.clicked equals false. Self.response data is none. Self.kill threads is false. And to make debugging easier, let's register these callbacks to standard out. And let's also keep a reference to these callbacks so we can interact with them later. Oops. Fix this typo here. Next, we want to set our extension name. Extension name, and let's call our extension bind shell. Next, let's create our actual tab, and that's going to be a swing JPanel, and let's use a regular border layout. Now let's add a custom tab to the Burp user interface. So callbacks.add suite tab self, and we can return. And now let's also implement these functions that are required by the API. So define get tab caption self, and we'll return bind shell, get UI component self. We'll return our tab that we just created. And again, we can see that these are the expected components from the Burp API. And let's try and load this up into our extender tab. So we can go into the extensions here, click add. We want to use Python for our extension and select our file. And now Burp will try to load our extension, and we can see if we have any errors, and we don't. And now we can see that we've added our own tab here within Burp, and the tab is empty because we actually haven't done anything yet. All we've done is implemented some of these API functions. And just to show an exception, we could make a mistake here like this. And now if we try to load our file again, we can see some errors here that we can work with. Attribute error, Java package object has no attribute, JS blah blah blah, and we can see that typo that we added, and we can also see the file. And we can see that if we aren't using this helpful function here, we can try this same thing again and see the error that we get. And we can see that for us as Python developers, this error is much harder to identify, debug, and fix. So let's keep using this and fix this up. Now that we have our basic template working, we can actually work to make this more useful by adding more components to our extension. So what we want to do is add more components onto our tab. So let's do that by creating a text panel as a J panel, creating a vertical box, creating a horizontal box. So these are again all of our GUI components. Let's add some text areas that we can interact with. So for example, we want to include the ability for a user to enter the IP address that they want to connect to for their bind shell. Make this a bit bigger as we go here. This is the size of our text area. We want to wrap the lines here as well. And let's add a border so this looks a bit nicer. And now that we've created this text area, let's add it to our horizontal box. And let's add this horizontal box to our vertical box. Now a user can enter the IP address where they want to connect to, but we also want the user to be able to enter the command that they want to execute on the remote system. So let's create another text area that we can use for that, for entering a command. So it's a similar process. Let's create another horizontal box. Let's call this one user command. And again, create a text area of the same size. Let's also set the line wrap and add a border. Command and add this. The horizontal box, and then add our horizontal box to our vertical box. And then to our tab, we want to add our text panel. We can take a look at this now. So let's reload our extension. Okay, no errors, that's good. But we forgot to add our box to the text panel, so let's do that as well. Box vertical. And we can reload this again by clicking this check mark. And so now we can see that our extension is starting to take shape. So we can add an IP address here, and we can also add a command here. However, we don't have any way to connect to a system. We don't have a way to disconnect, and we also don't have any buttons to send any commands. So let's include that functionality as well. Let's create some buttons. Let's first create another horizontal box. and a panel for our buttons. Let's create a connect button. And we can say here, connect. An action performed here is what will happen when we actually click the button. So this is a function that we'll need to add. And we also want a send button. So send command. And we also want to do something when this is clicked. Send. We also want to add a disconnect button. Disconnect. Dot disconnect. And by default, we don't want to be able to press the disconnect button because there'll be nothing to disconnect from. And we also don't want to be able to send anything because there'll be nothing to send or nowhere to send anything to. So let's disable these buttons by default. And now we want to add our button panel. So we can add that to our horizontal box. And add our horizontal box to our vertical box. So now we have our buttons, and we now also need to add these functions. So the things that happen when the buttons are clicked. Send. And button clicks are associated with a type of event. So we won't do anything yet. We'll just check this works. Same for connect. And disconnect. Let's take a look at this in Burp. We again go to extender, unload, and reload. And we can see that we have an error here because we have a typo performed without an R. So let's fix this. Performed. And reload this now. Just alt-tabbing between the windows. And next, let's create our text area. So this is where we can see the interaction between Burp and our bind shell. Create another horizontal box. Set up a text area. Add a line wrap. And we don't want the user to be able to edit this text area, but we do want the user to be able to scroll in here. So let's add a scroll pane. And add this. Save this and reload it. And we can see that our buttons are missing. So let's fix that up in our GUI because we forgot to add them to our button panel. So let's do that. Add the connect button. Let's add the send button. Let's add the disconnect button. Now we can reload this. Disconnect button, not the function. Reload. And now in our bind shell window, we can see our GUI that we could use to interact with our bind shell that we created in the previous project. So we could enter an IP address here. We could connect to the bind shell. We could enter some command. And we could also see the output. But we still don't have a way to actually do anything when these buttons are pressed. And we also don't have a bind shell which we can interact with. So let's start by running our bind shell. And we want to listen. So we can see our bind shell has now started. And let's start by implementing the connect function. So this is how we'll actually connect to our bind shell. So first, we want to create our socket. And we want to connect to the IP address which the user enters in the text field, which we can access with self.ipaddress.text, and the port that we want to connect to, which is 1234. We want to tell the process not to kill any of our threads. And then once we connect, we need to set up a few threads. And that's because we need to be able to send and receive data at the same time without hanging the already existing Burp GUI. So let's do that with threading. We need a send thread. We can start that thread. We need a receive thread. Let's start that thread too. And then we need to do some cleanup of our GUI. So we want to disable the connect button. Because we've connected, we don't want to be trying to press that button over and over again. However, we want to enable the user to now be able to press the disconnect button in case they want to disconnect from the shell. We also want to enable the send button. We want to disable the IP address button, because this is the IP address to which you've already connected. We can also print out some useful message here. Connected to bind shell. And we can handle any exceptions. So if something goes wrong during this connection process, we can say could not connect, try again. So now we can connect to a server. Let's also implement functionality to disconnect from the server. So let's send exit to the bind shell. So we can tell the server that we want to disconnect. We can also close our socket. We can tell our process that we want to kill our threads, and we'll implement this later. We also want to clean up our GUI. So we want to enable the connect button because now the user might want to connect to a different bind shell. We want to disable the disconnect button. We want to disable the send button because there's now nowhere to send commands. And we want to enable the IP address button because we might want to connect again to a different IP address. And we can also update the output text to say disconnected from bind shell. So now we can connect and we can disconnect, but we also need to be able to send data. And we can specify self.clicked equals true. And this is a variable that we can later use for talking to our threads. We're also going to add a sleep here for half a second. And we'll say self.output.text equals self.response data. And using time.sleep here is not necessarily good practice, but we are hackers after all. Because what we're actually introducing here is a bit of a race condition, but this process is useful to prevent the Burp GUI from locking up. And we're preventing this lockup by using our send and receive thread, and then also using a shared variable, response data, to talk between those threads. And again, this is not necessarily good threading practice, but for our hacking purposes, this will work just fine. So let's create those threads. We need a send thread. And we just want to infinitely loop in our send thread. And we want to check whether we've been told to kill our threads. So if we're being asked to kill ourselves, then we can do that. So this is a way to communicate between the threads. And otherwise we can check whether a button's been clicked or not. If it's been clicked, then we can say that we've processed the message and set it to false. And then we want to send the data through the socket that the user is trying to execute on the remote system. And after sending it, we also need to be able to receive it in this thread. And again, we'll use an infinite loop here. We'll check if we've been asked to kill ourselves. If we have, we'll die. And now in here, we can receive the data on the socket. And just to make this GUI experience a bit cleaner, we can get rid of some of the default information that gets sent from the socket. We can just remove that. If we've received something, we specify the response data to be that data. And again, we don't want to be directly updating the view in this receive thread, because if we do that, then our Burp GUI will hang. So what we're actually doing here is we're using these three threads and we're hacking together a way for them to talk to each other, or rather to communicate data amongst themselves. So when the user clicks the button to send a command to the server, we turn this click variable to be true. Then we sleep for half a second. While we're sleeping, our send thread will pick up that we've clicked the button, so we've set this variable to be true. It will then set that variable to be false, so we'll only process the command once. Then it will send the data that the user's entered to the socket. And then, at the same time, the receive thread is trying to receive data from the socket, and if it does, it sets this variable response data to be that data that it received, and then in send, we update the output.txt with that response data. And by adding this sleep function here, we're basically hoping that this process takes less than half a second to complete. And again, this is not good thread-safe programming, but for our purposes, this should work just fine. So let's test that out. Let's reload our extension. That's loaded without any errors. We can see our interface here. We also have our bind shell listening. So let's try to connect. It's 127.0.0.1. It's listening on port 1234. So we can try to connect. And we can see that when we press connect here, a new user has connected to our bind shell. And now we can enter commands to be executed on the remote system. So we can see, we type in who am I, the server receives the command to execute, it executes the command, and we can see the response here within our Burp extension. And again, our extension is doing this by making use of a number of threads. So we click the button to enter our command. This thread slept for half a second. While it was sleeping, the send thread picked up the message and sent it. The receive thread received the response and updated the response data variable. After the sleep was completed, the GUI thread then updated the output text with the response data so that we could see the message returned by the server. And we can see that this isn't perfect, because in that case, half a second wasn't enough time to sleep. However, this works fine for our lesson. But that's it for now, and in the next lesson, we are going to cover an introduction to Python debugging.